Hey guys, welcome to Mr. Soto's Precal class. This is the beginning of set builder interval notation. We just talked about the number sets. Now we're ready to talk about the set builder notation. So if you look at example 1a, I have this set right here. The elements are 1, 2, 3, and then there's 3 dots after that. The 3 dots represents that it's going to keep going forever. So 1, 2, 3, dot, dot, dot is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, forever. When we start talking about set builder, we're always going to open up set builder notation with a curly brace. And then we got to define x. This is what we're looking for, x. And then we draw this vertical line. This vertical line means such that. So far, this is what we have, x such that. And now after the bar, we got to describe the rule. We have to describe a rule that's going to mention what elements are in this set. So looking at this set, it goes 1, 2, 3 with 3 dots. If we look back at our notes, we have the set of the natural numbers, which starts with 1, 2, 3, and then there's 3 dots after that. The set of natural numbers is right here. So we don't even have to create a rule in this example. We can just go ahead and start by describing that x is an element of the set of natural numbers. And that will be your set builder for example 1. X such that x is an element of the set of natural numbers. Of the set of natural numbers. Okay, looking at example 1b. I made example 1b very, very similar to example 1a. It starts with 1, 2, 3, dot, 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 and then there's 100. This one has a stopping point. The other one did not. So we cannot put the same set builder because this one stops at 100. We have to describe in a rule that it stops at 100. So again, set builder, SB for set builder. We're going to go ahead and open up the brace, x such that. Now we got to describe what's happening in the set. We're talking about the natural numbers, the set of natural numbers, starting at 1, 2, 3, and then it goes forever. But in this case, we stop at 100. So the way we mention this set in a rule is that we get the smallest number, and then we get an inequality. 1 is going to be less than or equal to x. And then x has to be less than or equal to the biggest number. The biggest number is 100. We separate it with a comma. From the vertical line to the comma, that becomes the rule that describes the set. X is in between 1 and 100, and x equals to those numbers because those numbers are found in the set. And then in the end, we got to describe what set of numbers we're talking about. Is it the natural, the whole, the integers, the rationals, irrationals, or the real? And just like before, this is the set of natural numbers. X is an element of the set of natural numbers. That's example 1b. Okay, looking at example 2 over here. 2a, we have this set right here. Dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. It keeps going in both directions. I'd like for you to pause the video right now and try and see if you can do this set builder on your own. Okay? Go ahead and pause it, try it, and then we'll check it. Okay? We are back. Let's see if we can get it. Let's see if you got it right. Using our set builder notation, we have open brace, x such that if we look at the elements in the set, they look exactly like the set of integers. The set of integers is the z, and it starts with dot, 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 negative 3, negative 2, negative 1, all the way to infinity, right, in the positive direction. So here, we can go ahead and describe that x is an element of the set of integers. And then we close it. That would be your set builder for this example. The set of integers. We don't have to describe a rule because it's exactly like the set of integers, kind of like example 1a. This is exactly like the set of natural numbers. We don't have to describe a rule. Looking at example 2b, 2b is similar to 2a. If we look at the set, it starts with dot, 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 negative 3, negative 2, negative 1, 0, 1. Again, go ahead and pause the video, try to see if you can create your own set builder, and then see if it matches the one that I'm about to write. Go. Okay, we're back. So let's see. Our set builder is going to start like this. Open brace. X such that. Now we're going to create a rule that's going to describe this set. It doesn't continue forever. It stops at 1. 1 being the highest number in the set. So how do we say that 1 is the biggest number of them all? X has to be a number that's going to equal to that or less. So we're going to go ahead and write that X is less than or equal to the biggest number, 1. Then we separate it with a comma, and we got to describe the set of elements that this belongs to. X belongs to the set of integers. And that will be your set builder for this one. Let's look at a different example. For example, number 3, over here. We have X is less than 7. Here we got to create a set builder that's going to allow us to talk about this. So we're going to go ahead and start with the open brace. X such that when they give you an inequality already, you can use that as your rule. X has to be less than 7. So X is less than 7. Now you got to describe the set of elements that you're talking about. So when we talk about the elements, X is an element of what set? We can talk about the natural numbers, the whole numbers, the rationals, and all of those. So let's start with the smallest set. The smallest set is the natural numbers, right? So if we talk about the natural numbers, we can pick an element from there that's less than 7. Like for example, 6. 6 is an element of the natural numbers. 6 is less than 7. So yes, the natural numbers can work. But you always want to try to find a way to disprove that example. So what would be an element that is outside of the set of natural numbers? If you look at the picture, the Venn diagram that we just did, we have the whole numbers that's next. Whole numbers consist of 0. So if I change 0, the 6 to a 0, is 0 an element of the natural numbers? No, it's not. And 0 is less than 7. So because we found an element that is outside of the set of the natural numbers, then it cannot be the set of natural numbers. And then you have to find another way to disprove that it's not going to be the set of the whole numbers, because 0 belongs to the whole numbers. So what's an element that is outside of the whole numbers? If you look at the next set, outside of the whole numbers, it would be the set of integers. So we got to think of an integer that is less than 7. Integers go into the negative, so any negative integer would work. So let's just say I choose negative 1. Negative 1 is an element of the integers. Negative 1 is less than 7. So we already found an element that is outside of the set of the whole numbers. Therefore, it cannot be the set of whole numbers. And you keep doing this method until you find that you can't go any further. So for example, I'm going to go ahead and skip to the irrational set. If I can find an element that is outside of all the rational numbers, and it's found in the irrational set, then I know that it can't be any one of those rational numbers. So a rational number that we can think of would be pi. Pi is an element of the irrational numbers. Pi value is 3.14 if we round it. So 3.14 is less than 7. It's following this rule. So because pi is an element in the rational numbers that follows this rule, then we can say that it's not going to be the rational numbers, because pi is not in the set of the rational numbers. So we know it's not going to be the set of integers or the set of the rational numbers. But at the same time, we have found that 0 and negative 1 are elements that work with this example, this rule. And these elements cannot be found in the set of irrational numbers. So if it cannot be the irrational numbers and it can't be the rational numbers, then we're only left with the set that covers them all, which is called your real numbers. Your real numbers is the universal set. It has to be an element of the real numbers. Then we have example number 4, all positive multiples of 3. So in this example, we're going to go ahead and start with the curly brace. It's going to look like this. X such that, now we're going to create a rule that allows us to talk about all positive multiples of 3. So first of all, we're talking about multiples of 3, right? So how do you find multiples of 3? Multiples of 3, as long as you multiply by 3, you're going to end up getting a multiple of 3. So for example, 3, 6, 9, 12. These are all multiples of 3, right? So how do we get 3? Well, 3 times 1. How do we get 6? 3 times 2. 3 times 3. 3 times 4. So this is the equation that we're going to end up filling in here. But of course, we can't specify which equation we want to use. we're going to use a general equation. X is going to equal to, if you notice here, all these 3's stay constant in every equation. Therefore, an equation has to have a 3. And if you look at the numbers that they're being multiplied with, they're changing, right? These are changing. And every time a number keeps changing, we can call that a variable because we can change a variable. So here we're going to use any variable that you like to use. A, B, C, D, as long as it's not the letter X. If you use the letter X, it won't make sense. So we're going to go ahead and use the letter N. Just an N for number. 3 times any number. We separated with a comma, and now we got to describe what number are we talking about. This N has to be an element of what set? Can it be the natural numbers? If we use the natural numbers start with 1, 2, 3, 4, 5, and it keeps going forever, right? But the thing that works about the natural numbers is that they're positives. And we want all positive multiples of 3. So it looks like the set of natural numbers might work. Let's see. Let's try to disprove this. If I use a set of whole numbers, the whole numbers has a 0, right? If I use a 0, I'm going to get 3 times 0, that's 0. Is 0 a positive number? No. 0 is a neutral number, so you cannot use the set of whole numbers. So the set of whole numbers would not work. And since the set that is right outside the set of natural numbers didn't work, then none of the other sets are going to work. So that means it has to be a set of natural numbers. So this is a little bit of a set builder notation. This is how you're going to be writing your answers in your set builder notation. Thank you guys for watching, and I hope you learned something. If not, go ahead and ask me when you get to class.